we're going to take a look at transforming functions, and we're going to build on that investigation that you did yesterday with the calculators. So first thing I want you to do is pause the video and then see if you can find the inverse of this function. So remember, to find the inverse, we switch the x and y. So we have x equals 4y over y plus 1. And then we have to solve for y. So we can't have our y's in the denominator, so we'll multiply by y plus 1. So if we distribute, we have xy plus x equals 4y. Subtract xy. So you have x equals 4y minus xy. And this is the part where we sometimes get stuck. We're going to factor out the y. So we have y times 4 minus x, and then we'll divide by 4 minus x. Oops, 4 minus x. So we end up with y equals x over 4 minus x. So our inverse, using inverse notation, and there we have our inverse. Now, we're going to work on that translations. And you guys figured these out yesterday. If we add k, it goes up vertically. If we're subtracting some value, down. And then the left and right, again, those are always the opposite. And so, for example, if we had, this would be like x squared plus 2 would move it up 2. X squared minus 2 would move it down. X plus 2 squared would move it left horizontally, whereas x minus 2 squared would move it right horizontally. So there's another way that you can write this as well, and that is in vector notation. And you'll see it written vertically, where that first part is your horizontal and the bottom is your vertical. So 2, negative 3 means you move to the right 2 and down 3. Where this one means there's no horizontal, but that 4 would mean that you're going to move it up 4. So we're going to graph these here, and we haven't done any like this before. We're given a graph, and x plus 1, so that's a horizontal, so that means we're going to move it to the left 1. So we can take every coordinate here, and we'll move it to the left 1. So there's that piece of it. The second one, the minus 2, moves it down 2. So we go back to our original, down 2, down 2, down 2, down 2, down 2, down 2, down 2. And then this last one, minus 1, would move it to the right 1 and up 1. So to the right 1, up 1. Now it's this coordinate to the right 1, up 1, right 1, up 1. This coordinate, right 1, up 1, right 1, up 1, right 1, up 1, right 1, up 1. And we end up with that third one there. So now we're going to talk about the reflections and stretches, and these are usually a little bit more challenging for people here, but we're going to talk about horizontal and vertical stretches. If we're multiplying q, for example, if we had like 2x squared, this is a horizontal compression, and it's by a scale of 1 over q, so 1 over 2. So that means it's going to make our parabola narrower. But if it is outside, for example, if it's like 2x squared, it's a vertical of 2. So this will make it rise faster. And then if we have negative x squared, that's a reflection over the x-axis. But if we had negative x squared this way, that's a reflection over the y-axis. So we always have to watch, is that inside or outside the parentheses. So let's see if we can figure out some of these. That negative x, it's inside the parentheses, so that's a reflect over the y-axis. We could list things here. This one, it's the x, and when we think about this, f of x is our y value. So we're taking the opposite of y, so we're flipping it down. So that has to be the x-axis. The 2 on the outside, let's see, that's a vertical stretch by 2. And the 2 on the inside, if it's inside parentheses, it's horizontal by 1/2. So let's first start with this y-axis. So that one, this would stay here. Here's our y, so it reflects. This one's over 2, over 2, 1, 2, 3, 4, over 4, so 1, 2, 3, 4. This one must be 5. It must go up that way. So that one's pretty easy. The x-axis, so this one would stay, go down, down 2, down 2, and then this one would go down 4. And here's where they get a little trickier. Vertical by 2. I might even name these coordinates here. 0, 0. This one is 2, 2, 4, 2, and this one would be 1, 2, 3, 4, 5, 6, 4. So vertical by 2, that means we're going to double our y value. So 0, 0 stays the same, but it becomes 2, 4. 4 stays the same, but that becomes 4. And 6, 4 becomes 6, 8. So this would be 2, 4, 4, 4, and 6 and 8. So you can see it's a vertical stretch there. Horizontal by 1/2. This means you multiply the x's by 1/2. So let's see, we'll do this one in brown. And so instead of 0, 0 would be the same thing. Instead of 2, 4, it becomes 1, 4. 4, 4 becomes 2, 4. Oops, and I'm doing the wrong one. Sorry about that, guys. I was doing the vertical stretch. So let's take a look at our original here. 2, 2 becomes 1, 2. 4, 2 becomes 2, 2. 6, 4 becomes 3, 4. So you can see here it's shrunk horizontally. Now, what is the shift given to x squared? -3. Well, that moves it to the right 3 because it's inside the parentheses. +4, that would move it up 4. +1 moves it to the left 1, and then we're taking the opposite of that y value, so that would be a reflect over the x. And if you're not sure, I always can go back here. It's on the outside, so it's a reflex over the x-axis. 3 times this, well, let's see, when that 3 is on the outside. Oops, I missed that there. Let's see if we can go back and find it. 3 is on the outside is a vertical. And 3 is on the inside, so that's a horizontal of 1/3. But then we're taking the opposite of our x value, so that has to be a reflect over the, let's see, opposite x reflect over the y-axis. Because we had an x, but then it's going to the opposite. So let's take a look at a couple more. We're doing 2 times our function here. And we have a vertical. And so this is times 2. So I'm going to name these coordinates again. 1, 2, 3, 4, 4, -2, 0, 2, 2, 0, 1, 2, 3, 4, 5, 4. So here we go, vertical times 2. So this is 4, -4. This would become 0, 4. 2, 0 would stay the same, and this would become 5, 8. So there's our vertical stretch. I like these. These are just left and right. So we go to the right 1 and up 2. So we go back to our original, right 1 up 2, right 1 up 2, right 1 up 2, right 1 up 2. Let's see. We're taking the opposite of our y value, so that has to be a reflect on the x-axis. So again, to our original x-axis, so this would become here. Whoops, that 1, 2, so it would go here. 1, 2. This one would stay the same, and then it would come down. 1, 2, 3, 4. And 1/2 x. So this is a horizontal, and it's 1 over 1/2, which 1 divided by 1/2 is 2. So it's a horizontal by 2. So let's see. We have -4, -2, so this becomes -8, -2. 0, 2, so that stays at 0, 2. 2, 0 becomes 4, 0. And 5, 4 becomes 10, 4. And there we have it. And here's your assignment.